The first activity that we're going to do in lab is looking at rennin and milk and trying to figure out how temperature can affect enzyme. So here the enzyme is the rennin. And rennin is really important for infants. So to give you a background about rennin. First, a little bit background about rennin. So the rennin that we're going to be using in this lab is actually provided as a tablet. This rennin was found in mammals' stomach lining. So here, this rennin is coming from a cow. And this rennin is available for you to purchase because we can actually take the rennin, and the rennin again is an enzyme. We can take that enzyme, and if you apply it to milk, it can actually form cheese. So the rennin that we're using in lab today, you can actually purchase to make your own cheese at home. This rennin is a naturally occurring enzyme that's found in the stomach lining of mammals. Why do we have this enzyme? Well, this enzyme is able to convert a certain substrate found in milk, the casein, into pericasein, and eventually it can solidify the milk so that the milk can remain longer in the stomach. Why do you think this occurs in mammals? Well, mammals, young, rely on this milk in order for it to gain its nutrient and grow. However, milk is very runny, right? Milk is a liquid, it's super runny. So you can imagine that if the infant was to drink that milk without the milk being able to solidify, it would basically just run through the infant. There isn't enough time for the infant's body to really absorb the material in that milk efficiently. So by solidifying the milk in the stomach of these infants, it can stay in its digestive system for a little bit longer, and it can be digested more efficiently than if it was not solidified. So milk can become solid by using this enzyme. Milk will respond really similarly if you were to expose it to acidic situation as well. So here we have some example of the milk, and if you add the acid to it, it can solidify. And you can see here, if you add the rennin, it will also solidify into little curls. So that is what we're going to observe in a lab today. So this is today's laboratory. So if you open up the lab manual, you can go to rennin and temperature and follow along. So we're going to be using rennin as our enzyme today, and this is the source of where we get our rennin from. So you can see it is actually made for cheese making, which is what we're going to do today, right? So in your mortar pesto, you will have one of these tablets, these rennin tablets right here. And what you're going to do is that we're just going to go ahead and place it in our mortar and pesto, and we're just going to grind it up. So you can see it start off like that. So you're just going to grind it until you get a powder like that. Now using a graduate cylinder, we're going to get 15 milliliters of water. So let me just finish filling this up. So this is the 15 mark here, right? So we're getting 15. It's a little bit over, but that's fine. And we're just going to add to the speaker our rennin powder. That just have water, excess water in it, right there. And we'll add our 15 milliliters. So this is our solution right now. This is what contains the enzyme. So this is the rennin and the water, and this contains the enzyme. 6 test tubes set up here. These 3 will be for my rennin, and these 3 right here will be for my milk. So I'm going to add roughly 1 inch worth. So basically 1 knuckle worth. It's going to be roughly 2 to 3 milliliters. and I'm going to add it to the test tube accordingly. Okay, so what you just saw is this first step where we crushed the Rennin and we placed it into the garage cylinder to get 15 milliliters of the solution. And then you saw me show you 6 test tubes, with me saying that 3 of them are going to be for the enzyme, the Rennin, and 3 of them will be for milk. So this is kind of where we're at right now. So what we're going to do next is we're going to allocate the milk and the Rennin to the appropriate test tube, and we're going to pre-treat them. So these are the 3 conditions that we're going to look at. Each of these conditions vary on the temperature. So we're going to have 3 conditions that I'm going to show you in the next clip. We're going to have an ice condition, which is roughly 0 degrees Celsius. So this represents the enzyme being really cold. Is the enzyme still functional? Is it still active when it's cold? Technically, yes. The enzyme is still functional and it could still be active, meaning that it can convert that reactant to product. But what's the likelihood? Pretty slim, because similar to you and I, when the enzyme is that cold, it's not going to function very well. It's cold. Yes, it could go out and look for those substrates to help find their mate and make it into a product, but it's really cold and would prefer to be underneath this warm blanket. It would prefer to be at the ideal temperature, which is body temperature. That's our second condition. Our second condition is mimicking the body temperature. So this is the condition in which the enzyme works the most ideal. Similar to like when we have a fever. When we have a fever, our body doesn't feel that great. And the enzymes, similar to what we mentioned before with the egg white, when the enzyme is placed at a higher temperature, it starts denaturing and it starts becoming inactive. By becoming inactive, we mean that the enzyme is no longer able to find the substrates to convert its product. So in this case, the condition is going to be a boiling condition. So it can be either hot or boil. It's labeled as both in your lab manual. But in this condition, we're going to use a boiling condition where the temperature is roughly 100 degrees Fahrenheit or roughly 38 degrees Celsius. So here we're mimicking a situation in which we have a fever. So you saw that I had set up 6 test tubes. 3 of them are going to be for the Rennin, and 3 of them are going to be for the milk. And they were labeled as CR, WR, or BR. So we're going to place them either in the ice bath, the water bath, the warm water bath, or the boiling water. And it's going to be placed, you'll see that I placed it in 6 minutes, and then I'm going to move it into the 37-degree water bath. This is just to get the enzyme to come back down to 37 degrees before I treat the milk. You'll see that I will also preheat the milk, which is the substrate. So I'm going to have 3 test tubes. So you saw that I show you CM as well as WM and BM. So these are our test tube with the milk, and we're going to pre-treat them into different temperature. Let's switch it around and add. To our different water bath. This is our warm water bath at 37. You can see that's at our ice bath. At least here we have our hot bath, right? And this is at 100 Celsius. Bath, right? And this is at 100 Celsius. Here, and I'm gonna place the cold enzyme into the ice bath right here. The cold milk also into the ice bath right there. For our warm Rennin, I'm going to place that as well as the boiled Rennin, right? So the warm rennet, I'm gonna place it into the water bath. Right here. The boiled rennet, I'm gonna place it into here. And we're gonna leave it there for 6 minutes. Now we have our 2 warm milk and boiled milk. Both of these will go into the 37 water bath. So you just saw us set up the different test tubes. So the R test tube, if you recall, one of them was in the ice bath, one of them was in the water bath, and then one of them we placed in the boiling bath. So that's going to be there for 6 minutes. So in 6 minutes, I'm going to move this test tube into the warm 37 water bath. So in 6 minutes, I'm going to move it back into the water bath. The milk was in the ice bucket for the CM. But then if you recall, both of these, you saw me place it into the 37. Right? So both the WM and the BM were placed inside the 37 degree Celsius water bath. And that's because milk, if we place it into the really hot temperature, what happens? Think about when the last time you made hot chocolate. If you were just to place that milk and we boil it, there's a good chance that on its own it's going to start solidifying and forming that milk solid layer. And we don't want that layer to be formed because we're trying to test what happens to the enzyme during these different temperature conditions. So we do not want the milk on its own to form any type of solidification because that wouldn't help us understand the enzyme. So that's just what you saw me doing, is placing them to these 3 conditions. So 6 minutes here, and it's going to be placed in here for roughly 5 minutes or so. So we're not going, everything, all the other test tubes are in their condition. Once this hot test tube has sat in the boiling and then moved to the warm temperature, and it's been 5 minutes, we will remove all the test tubes, and now we're going to actually mix the 2 tubes together. So the cold and the cold will be mixed together, warm and warm will be mixed together, and then boil and boil will be mixed together. Okay, boiling Rennin right here, and I'm going to place it into the water bath. So boiling into the water bath. And I expect that in these 3 conditions, that the boiled rennet should be denatured and no longer active, that the warm rennet is probably pretty happy, and that the cold rennet is probably still active but not moving much. So I'm going to go ahead and grab 1 tube of the boiling, and I'll place it into the boiling milk. I'm now going to return the milk with the rennet back into the appropriate bin. So for the boil, it's going to go in 37. The warm is also going to go in the 37. And then the cold is going to go right there in the ice bath. Okay, and we're going to wait 5 more minutes. Okay, let's collect our test tube. So this is the cold Rennin. You can see it's pretty liquidy. Right. And let's look at the warm. So this is our warm. And it's pretty solid. This is pretty much cheese. Right. And then our hot, our boiling, pretty liquidy. as well. So we just saw that we mixed our enzyme and our substrate together, and then we placed them back into the ice bath for this guy. And for both of these, after we mixed the rennin and the substrate, we placed them back in the water bath. Why do you guys think we went and we re-incubate them into the water bath? So here's our lab manual. So this is the step that we're on, step 4. We place them back in there, and it's gonna sit there for 10 minutes, and then I showed you the results where in the cold, if you remember, the milk did not curl. So this would be a no. In the warm bath, we saw that it completely had solidified, right? So this would be a yes. The milk had become solid. And in the boil, we also saw that the milk did not solidify. So no, yes, no. What about this section? Was the enzyme active? Well, for here in the warm temperature, we know for sure the enzyme was active because it was able to solidify the milk. The boil, not likely, because the enzyme most likely got denatured. And what about the cold? Well, the cold, the enzyme probably would be active, but we didn't see any activity because it was too cold of a condition. So this was almost like a trick answer. In a way, it was active, and if we had left it there overnight, we probably would see some curling. Or if we had left it, removed them and put them at room temperature, the next morning, you would probably see some milk solid. So the enzyme is active, but it's just very slow. So we couldn't observe in that 10 minutes. And why did we incubate it in the 10 minutes? We incubated the test tubes for 10 minutes in those conditions to allow time for the enzyme and the substrates to actually meet, right? So if we had just measured right after, you wouldn't have seen any solidification because the enzyme didn't have enough time to work with the substrate to produce a product. So we had to give it enough time so we can actually see the reaction happen. All right, that's it for this activity. The next activity that we're going to move on to is the catalase and pH experiment. So I'll see you in the next video.